Welcome to the final episode of The Great Library. It's hard to believe that through the entirety of this project and the journey from the seed of an idea to a fully constructible model, our project stakeholders have never met in person or visited the site. That is, until now. In this episode, we'll conduct all the final checks that will take place on site before a project like this would move into the physical build. We'll mix digital and physical, overlaying and exploring our digital twin and all the detail within it, in the space where it will ultimately be committed to glass, steel, and concrete. We'll take a look back at all the processes that have enabled us to get here, and also look forward to how connected construction will continue to lead the project all the way through to the handing over of the keys. It wasn't just our architects and engineers meeting in person for the first time. The project owner, Matt, was the next arrival, closely followed by Adil, our field technology expert.
We've all shared work, but we've never been in the same place and never been on the site.
While Frank, Julie, and Einstein stepped back in time, exploring more of the ancient site. Matt and Adil set their sights on an altogether more futuristic view of the library.
How does the XR10 work, and how does it help us here?
Well, this is an XR10, so an approved helmet equipped with HoloLens 2. Really, the huge benefit is it's using holographic technology to merge digital content with your surrounding or to display digital data. So we have a immersive experience.
It allows us to take all the detail of the model that we've got, put it into this real world so we can actually walk around it one-to-one scale. We can interact with all the different pieces.
Exactly. The XR10 allow you to streamline workflows, eliminate errors, increase transparency, and radically reduce the project delay. It can allow you to have the remote collaboration capability, which will allow to the user to stream live to stakeholders, to off-site stakeholders. It's a huge benefit for remote collaboration, for example. Yeah.
So people can share what I'm seeing anywhere in the world through this camera on the front of the device.
Exactly.
Okay, yeah. Amazing. Well, why don't we go and have a look at it in the building?
Yes, of course. Let's go.
Matt has been a constant throughout this project, from the day where the idea was first surfaced to seeing it all today on site. Having seen it all develop, every build, every interaction, how does this moment live up to the expectations?
We can see all of the steel structure. We can see the roof, the canopy over the top. There's the ductwork, the electrical. We can see the lights coming up from the bottom. And we can see exactly where they'll be in real space. So I can get a feeling being in here of the new structure as it would be before it's constructed. So typically before a building's constructed, you don't have the opportunity to stand in the space where you're going to be at post-construction and see what it looks like. You rely on 2D drawings. So using this, you can actually see everything as it will be before the construction happens. You can check for issues, you can check for any clashes. Are there points where there's steel which clashes, or that there is duct that clashes with any of the mechanical, which is a pretty unique experience.
Whether you're dealing with complex MEP like our Pixel Wall, or huge steel staircases that need to be prefabricated and installed, the peace of mind this technology brings is invaluable for any installation. The US Bank Center in Seattle is a great example of how nothing is left to chance.
It's an interesting structural steel project. It was built overseas, and none of the shapes are US standard shapes. And so they're all built up, fabricated members, built in the 80s, looked like it was built in the 80s. And so they're retrofitting the first 3 floors to modernize it and bring it up to a retail space.
One of a kind. Nothing like you've ever seen before. You can look through the entire block So you can stand on 5th Avenue and look at 6th Avenue by looking through the building. And then you'll have grand stairs that you're looking at, 2 of them, that come together. So those grand stairs you can see from the street as you look inside the building. I mean, the space is gonna just blow your mind.
The scanning technology allows us to fabricate stuff way more than we would have. I mean, these stairs were in 3 pieces. In the past, you might have actually stick-built them because you weren't sure they were gonna fit. Putting this stuff together like it's a brand new building on a retrofit job. And that's significant. The scanner allowed us to go in and actually measure what's here, and so we could make our steel fit.
We showed them what we could do with the scanner technology. We showed them that, you know, we had the capability, the know-how from our field team to come out and scan, through our detailing department to interpret those scans, to get them to work, all the way through the fab shop to make sure that, you know, everything and the quality of the steel that we're providing is good, and the logistics to work with the site to get it brought out.
The quality of our people is significant, and then once it gets to the shop, the fabrication, the welding, the quality control processes are also significant. So you have the point cloud, existing field conditions. You have the new model, you model it in, and so we build our drawings off of that new model. The shop people build off of those drawings. But then, once it was complete, we actually scanned the new steel of these stairs in the shop, and we were able to put the new steel point cloud into the old steel point cloud and make sure that it fit, made sure the shop guys built it per our model. And so when I say I can guarantee it's gonna fit, I have a backing behind that in the fact that we scanned this new steel and virtually put it together before it was here.
It saves significant time and money, which time is money. I mean, you do the math. If you save 4 days, 12 guys each day, I mean, that's thousands and thousands of dollars. So a significant amount of money, a significant amount of stress that's saved as well.
This is the point in the project where all of our digital and virtual design and planning is handed over to the team managing the physical build. I'm sure it's not a huge surprise, having chosen a UNESCO World Heritage Site as the heart of our project, that this is where our story has to end, or at least the development of a physical Great Library on this beautiful, ancient site. As the sun set over the Great Library, the team took the opportunity to raise a glass and reflect on the successes of the project and how it can continue to benefit the industry for years to come. How does it feel to be here on the completion of the project?
It's fantastic being able to add a structure like we did in the way that we did. It feels great. And I think we've proven that working in the way we planned really adds a value to a project. We have one single source of truth in that BIM model. There is not much room for misunderstanding. So no, I'm very happy with the way we did it.
This has been such a pleasurable experience, sharing the knowledge among all the people through files and through conversations and relying on, conversations of expertise, but then seeing it resolve in a real site. I hope that we can use this to show the conventional aspects of how we do things.
It shows how we can all work together to
Right.
create these things that we then can visualize through the technology on site. This is the way we hope that all projects will go in the future.
Seeing what people can collaborate and make, something that could actually be built down to the bolts, all of the air handling, all of the electrical work, everything done. Different parts of the world, different times, different locations, all from the same information. It is unbelievable.
BIM model looks the same in
Yes,
anywhere in the
absolutely,
world.
absolutely.
So It's a universal language.
Yeah, it's simple for me to read and understand, and anybody that we've given it to be able to digest the intention in the design, and then for us to see all the engineering work and those forms, and for that to then go into a detailing process where we can understand the cost.
We showed the 3D models to some of the tourists walking around here today. The enthusiasm in their faces when they saw what we were trying to show them was amazing. They immediately understood what we were planning to do.
Well, thank you so much, every single one of you. You've done such incredible work. So that's a wrap on the Great Library series. But this is really just the beginning. The Great Library lives on as an interactive metaverse experience freely accessible to the entire construction industry, housing all of the resources from the project and supplementary deeper and additional content from every stage of the process. There's so much to explore, so much to learn, and so much for you to apply in your own projects. Just search Trimble, the Great Library, or click the URL in the description. See you there.